Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. Good evening, children. Yeah, I think I had given this some as homework, correct?
Yes, ma'am. Yes, ma'am.
Okay. So we need to continue with this one. Am I right? I think I'd asked you to work this. Should we do this one now in the class?
Yes, ma'am.
Okay. A suitcase with measures 80 centimeters by 48 centimeters by 24 centimeters is to be covered with a tarpaulin cloth. So clearly from the dimensions, you can make out that the suitcase is cuboidal because you're given the length, the breadth and the height of the suitcase. So it's a cuboidal suitcase. Length, breadth and height is given to you. So it's a cuboidal suitcase. You need to cover the suitcase with a tarpaulin cloth. It's a material. Tarpaulin is a material like canvas, tarpaulin. Okay, so these are tougher materials. Now you need to cover the suitcase with a tarpaulin cloth. The question is, in the market, this tarpaulin cloth is sold um, where the width of the cloth is 96 centimeters. See here, how many meters of tarpaulin of width 96 centimeters is required to cover 100 such suitcases. So if you've ever gone to the market to purchase material, see now we go for ready-made clothing. So if at all you've purchased, material, fabric from the market, you will be specifying the shopkeeper the length of material you need. The material is rectangular. The material is rectangular. The material is wound, around a stick like this. That's the material, the fabric is wound. It's wound around a stick. Okay, so you can see many sticks placed vertically in the shelf. If you've ever visited a fabric store where they sell, material, the fabric is wound around a stick and the sticks are placed vertically in the shelf. So you choose the fabric, supposing you want this color, you need to specify what length of fabric you need. So you will say, give me 1 meter of this fabric or give me 2 meters of this fabric. Now this fabric is wound around this stick, and you can see that the width of the fabric is fixed. You cannot decide the width of the fabric. The width of the fabric will be fixed. It's a length which you can decide. See, when you buy the fabric, when you buy the material, it is rectangular. When the shopkeeper cuts the material and gives it to you, he'll fold it and give it to you. When you spread it open, it's a rectangular piece of cloth. When you spread it open, it's a rectangular piece of cloth. So when you have to buy material from the market, you will be specifying the length of material you need. What length you need? Give me 1 meter of this material. Give me 2 meters of this material. The breadth of the material is fixed. The breadth of the material is fixed. That will be fixed. It differs for different material. It need not be 96 for every other material. The width is different for materials. Meaning, see if you're buying a piece of shirt material will have a different width than a pant material, than a blouse material. The width of a blouse material will be different from the width of a shirt material, will be different from the width of a pant material. The width of different materials may be different. So you will specify, you will ask your tailor. So if you have to, get a pant and shirt stitched or some other clothing, say a salwar kameez, the tailor will specify. The tailor will tell you, get 3 meters of, the pant material and whatever, some 2 meters of shirt material. The tailor will take your measurements and he will tell you how much fabric you need to get a set of pant and shirt stitched. So you will demand that. You will go, not demand, you will request that from the shopkeeper. Your tailor will tell you how much fabric you need to buy, and that's what you will have to get from the market. So you will everywhere you will be specifying the length of the fabric. The tailor also will tell you the length. Get 3 meters for the top, get 2 meters for the bottom. Okay. So now coming back to the question. These are the dimensions of the cuboidal suitcase. Now, now you have to cover these. There are hundreds of suitcases. You need to cover these suitcases with this cloth, tarpaulin cloth. And this cloth is sold in the market. The width of the cloth is 96 centimeters. Now, the question to you is, now, if you want to get some dress stitched, the tailor will tell you, get whatever length of top material and some length of bottom material. Now, you have to decide. You have to decide how many meters of tarpaulin. So when you go to the market, what length of tarpaulin will you buy to cover these 100 suitcases? So how do we calculate that? How do we calculate the length of tarpaulin we need? If the width of the tarpaulin sold in the market is 96 centimeters, the width of the tarpaulin sold in the market is 96 centimeters. If the width is 96 centimeters, what length of tarpaulin you have to buy? What length of tarpaulin you have to buy? So this is the procedure. You should not find volume because you're not doing anything inside the box. Volume is to do something within the box, inside the box. It's not volume. It's the total surface area. You have to cover the 6 surfaces of the cuboidal box, suitcase. Doing anything inside the box. If it's something to do inside the box, then it's volume. How much liquid it can hold, or something to do with the inside of the box, it is volume. But now here you'll have to cover the 6 surfaces of the box with tarpaulin. You have to cover the 6 surfaces of the cuboidal box or cuboidal suitcase with tarpaulin cloth. What you will cover? You will cover the 6 outside surfaces. The suitcase is cuboidal. Outside, you can see 6 surfaces for the suitcase. You have to cover these 6 surfaces with the tarpaulin cloth. So you have to find the total surface area of one suitcase first. You have to find the total surface area of one suitcase. You have to find the total surface area of one suitcase and multiply that by 100 to get the surface area of 100 suitcases. Okay, so supposing the answer, the answer is 96, 1, 2, 3, so many centimeters square. Okay, that is you find the TSA of one suitcase multiplied by 100. So that will give you the TSA of 100 suitcases. And supposing this is the answer. So this is the area, the surface area of 100 suitcases. To cover this area with tarpaulin cloth. And the cloth so that means you should buy tarpaulin cloth which has an area of 96,000. The TSA of one suitcase into 100 will give you the TSA of 100 suitcases. So what does the TSA of 100 suitcases tell you? The surface area of 100 suitcases is 96,000 centimeters square. That means this area of cloth you have to buy. That means we'll have to buy this area of cloth. So the cloth, see it's rectangular, right? The cloth, the tarpaulin cloth is rectangular. So the area of the rectangular cloth, tarpaulin should be 96,000 centimeters square. What is the width? The width is 96. So what do you think should be the length of the cloth? What do you think should be the length of the cloth? What into 96 will give you this area? L into B is area, right?
100
Is area. What length into 96 will give you the area? How much? 100.
100 ma'am.
100 or 1000?
1000 ma'am.
1000. That's all it is. So area by width. You know that L into B is equal to area. L into B is area. You don't know the length. Into breadth 96. Area 96,000. So the length is equal to 96,000. I'm just saying, for example, by 96, which is 1000 centimeters. Now I'll show you the answer slide. So you can see here the area of tarpaulin. The area of tarpaulin needed to cover one suitcase. Area of tarpaulin needed to cover one suitcase is the total surface area. Is the total surface area. The area of tarpaulin. How much tarpaulin you need to cover one suitcase is the total surface area of the suitcase. What is the area of the material you need to cover one suitcase? What is the total surface area of the box? So find the total surface area of one box. So the area of tarpaulin needed to cover 100 suitcases will be 100 into this answer, which is whatever you see here. So many centimeters square. But how do we find area? How do you find area? It's rectangular, no? The cloth is rectangular. So you get area is equal to area of the tarpaulin. Area of the tarpaulin needed to cover 100 suitcases is this. And tarpaulin, that material will be rectangular. How do you find the area for rectangle? L into B. So L into B should be this value. L into B should be this value. So the length into the width is 96. Should give you this area. So the length will be equal to area by width. Area by width, which is 14,400 centimeters. 14,400 centimeters. Since it's more than 100 centimeters, you can convert it to meters. You can convert it to meters. Divide by 100 and convert it to meters. So the length of the tarpaulin needed is 144 meters. The length of the tarpaulin needed is 144 meters. Children, now, have you already finished writing this answer or should you write it now in the class?
Ma'am, I've started writing area of tarpaulin needed, so I'll finish it within a minute, ma'am.
Ma'am, now only we are also writing, ma'am.
Okay. Please write on, children.
Completed, ma'am.
All right.
Completed, ma'am. Completed, ma'am.
Okay, children. So since this question is about covering the outside of the box with tarpaulin, the cloth should cover the 6 surfaces of the cuboid. Hence, we have to find the total surface, not the volume. Find the TSA of one box, multiply by 100 to get the TSA of 100 boxes, and that area is equal to L into B. Because whatever is the surface area of 100 boxes should be the area of the cloth also. So equate that to L into B, where B is 96 centimeters. And finally, you are able to find the length of tarpaulin needed. Find the side of a cube whose surface area is 600 centimeters square. What is the formula to find the surface area of a cube? Surface area means surface area is always total surface area. If nothing is mentioned, it is total surface area.
Ma'am, actually, we discussed this question in the previous class, ma'am.
Okay, fine. Tell me the total surface area.
6A square, ma'am.
Okay, very good. Fine. This is over, is it? You're sure?
Yes, ma'am.
Okay. Surface area always means total surface area. If nothing is mentioned, if it's not mentioned curved surface area, if it's just surface area, it means TSA. So 6A square, TSA 600. That means 6A square because the total surface area, surface area 600. The surface area 6A square. It means equal to 600. 6A square is equal to 600. So on working, you find the side of the cube is 10 centimeters. This is not over, right? I asked you to work this.
Yes, ma'am.
So Rukshar painted the outside of the cabinet of measure 1 meter by 2 meters by 1.5 meters. He painted the outside. You can see the length, breadth and height is given. Just 1 second. Okay, so Rukshar painted the outside of the cabinet of measure. You can see the picture of the cabinet below of measure LBH given to you. How much surface area did she cover if she painted all except the bottom of the cabinet? So she paints the four side faces and the top. She does not paint the bottom. We know that a cuboid has 6 surfaces. 6 surfaces. Top surface, bottom surface, the side faces, side surfaces, side left and right side, then the front and back. front and back. Front surface, back surface. Left side, right side surface. Top and bottom. So she's painting everything. She's painting the top, the side faces, the front and back, but not the bottom. Of the 6, she's painting only 5. So how much surface area did she cover is the question. So you should find the CSA. Find the CSA plus the area of the top. Area of the top. Because the curved surface area will include 4 faces. And the area of the top front face. So 5 faces. When you find the CSA, you're finding the area of the CSA, the curved surface area. You're finding the area of the front face and the 2 side faces. 2 side faces, totally 4. When you find the CSA, you're finding the area of the front face, back face, left side face, right side face. This one, this right side, this one, the front face and the back face. That is the curved surface area. Now to the curved surface area, include the area of the top. Don't find the area of the bottom. She's not painting that. That will give you the area she's painted. So area not including the bottom is equal to CSA plus the area of the top, because the 4 faces plus the top area, bottom area is not included. So substitute in this formula 2h into L plus B, because that is the CSA of a cuboidal box. 2h into L plus B. Area of top, I told you last class we discussed, or the class before that. The area of the top is length, L into B. The area of the top, this one is length into breadth. Substitute the values. This is L, this is B, this is H. Substitute the values and find the answer. Yeah, do this. Finish, children. Is it over? Am I audible, children?
Ma'am, I think we completed this also in the previous class.
All right. No, I didn't explain. I'm explaining it only now.
Yes, ma'am.
Shall I go to the next one, children?
Yes, ma'am.
Daniel is painting the walls and the ceiling. Kindly disable your mic. All of you look into your mics. Please check if it's enabled, disable your mic. Daniel is painting the walls. So walls meaning the 4 walls. That is a curved surface area. Daniel is painting the walls. That means a curved surface area. And the ceiling, the area of the top. 4 walls means, I told you the other day, 4 walls meaning the curved surface area. Daniel is painting the curved surface area and the area of the top of a cuboidal hall, length, breadth, height given. from each can of paint, 100 meters square of area is painted. So from one can, he can paint 100 meters square. How many cans of paint will she need to paint? Will she need to paint the room? The commas are not given. From each can of paint, 100 meters square of area can be 100 meters square of area is painted. How many cans of paint will she need to paint the room? So tell me, how do we do this? Okay, now supposing I'll give you the question like this. Supposing you have, okay, you have a room. Okay, the area of 4 walls is 100 meters square. The area of the ceiling. Okay, the area of 4 walls. Area of 4 walls, children, is okay, so 1000 meters square. Area of the top, area of the ceiling. Area of the ceiling is some 200 meters square. All right, so what's the total area you have to paint? 1200 meters square. Now, supposing I say from one pot of paint or from one bucket of paint, you can paint 100 meters square. If you buy a bucket of paint from the market, that will help you to cover an area of 100 meters square. Then how many buckets of paint will you buy? Well, I'm scared if I'm clear or not. Am I audible and clear, children?
Yes, ma'am.
Ma'am, it's not clear, ma'am. Voice is not clear, ma'am.
Ma'am, it's breaking a bit, ma'am.
Is it?
Yes, ma'am.
Yes, ma'am.
Ma'am, sometimes it's slowed and then sometimes it's breaking, ma'am.
Oh my God. Okay, let me repeat this. Tell me if it's not clear, children.
Yes, ma'am.
Yes, ma'am.
All right, now see here, I'm saying, supposing the area of 4 walls is 1000 meters square, okay? The area of the ceiling, suppose the area of the ceiling is 200 meters square. What is the total area to be painted?
Area of the walls plus area of the ceiling, ma'am.
Now, yeah, what is the total area that is to be painted? Add and tell me.
1200 meters square, ma'am.
1200 meters square.
Yes, ma'am.
Now, in the market, if you buy 1 can of paint, from the market, you can use this paint to cover up an area of 100 meters square. If you buy 1 can of paint, you can use that paint and cover up 100 meters square. Then to cover 1200 meters square, how many cans of paint will you buy?
Ma'am, it's 1200 by 100, which is 12, ma'am.
Yeah. You'll buy 12 cans of paint. Class, first, is my voice clear? And then, did you understand?
Yes, ma'am.
Madhumita, my voice is reaching you clearly?
Yes, ma'am.
Okay, then if that is the case, then I think the issue should be something from your end, children. If it's not audible and clear for anyone, then I should check my Wi-Fi. But I'm concerned, others in the class, you're not responding. Am I clear? Danya?
Yes, ma'am.
Kirtna, can you hear me clearly?
Yeah, ma'am. At the beginning, it was breaking, ma'am, but now it's fine, ma'am.
Okay, Madhumita says it's fine. Kirtna, fine. Danya? Oh my God.
Ma'am, I think Danya has put her meeting on hold, ma'am, by mistake.
Yeah, that's what. All right, children. So supposing the area of 4 walls is 1000 meters square and the area of the ceiling is 200 meters square, then the total area to be painted is 1200 meters square. In the market, a can of paint has some volume of paint that's not given, but you can use it to paint 100 meters square, this area. So if you buy one, you can paint this much area. How much should you buy to cover or to paint this area? So as Madhumita said, it will be 1200 divided by 100, which is 12 cans. 12 cans you need to buy. Do the same thing here. Do the same thing here. Find the area to be painted. It's the area of walls and the area of the ceiling, which is 2 plus B plus LB. Ceiling is LB. So here I've substituted the values and the area of the 4 walls and the ceiling is equal to 500 meters square. From one can of paint, you can paint 100 meters square. So you need to buy 5 cans to paint 500 meters square, which is 500 meters square divided by 100 meters square, 5 cans. Got this, children?
Yes, ma'am.
Yeah. Please do this.
Ma'am, I wrote this already using the meeting recording, ma'am.
Okay.
Completed, ma'am.
Sindhu and Sanjay, is it understood clearly?
Yes, ma'am.
Okay. So 2h into L plus B is area of 4 walls. LB is the area of the ceiling. Why we are finding only this? Because he's painting only the walls and the ceiling. And obviously the floor is not painted. The floor is tiled. The floor will not be painted. Okay. Describe how the two figures at the at the right. I shouldn't have typed. In the textbook, it was, the figures were given to the right. Okay. Let's just take this away. Describe how the figures are alike and how they are different. Which box has larger surface area? Larger lateral meaning curved. Lateral meaning curved. Let's do it now. They are alike because both of them are solids, and they are different because a cuboid has rectangular faces while the cylinder has curved faces. The cuboid has, you can say that the cuboid has corners while a cylinder does not have any corner. The two figures are alike because both are solids. They are different, you can say, specify this. A cuboid has corners. How many corners does a cuboid have? Look at the room in which you're sitting. Count the number of corners in the room. Count. How many corners are there in the room you're sitting? How many corners? On the floor, how many corners do you see? On the floor. How many? How many? Sorry?
4, ma'am.
4 corners on the floor. And in the ceiling?
4, ma'am.
4. So totally you can see 8 corners.
Yes, ma'am.
See, like these are the corners. 1. I can't show you everything here. 2, 3, 4, 5, 6, 7, and somewhere here 8. Meaning like 8. Here's an 8th corner. All right. So you can say that both cylinder and cuboid are solids. Meaning they're 3-dimensional. They're 3-dimensional. A cylinder has no corners. While you don't have to, so you just say a cylinder has no corners, but a cuboid has 8 corners. Yes, children, write on this. Both of them are solids, so that's a similarity. A cylinder has no corners because the top and bottom faces, they are circular. A circle, you can't find a corner there. If you are in a cylindrical room, or if supposing you're in a cylindrical drum, a big drum, a cylindrical drum, you cannot hide yourself in any corner, or you cannot go to any corner. There is no corner in a cylindrical room or a cylindrical drum. While a cuboid has 8 corners. All right.
Completed, ma'am.
All right. Now, which box has greater, lateral surface area? Which box has larger lateral surface area? Lateral meaning curved surface area. What is the formula to find the CS of a cylinder? Have we discussed?
2 pi r h, ma'am.
Have we discussed in the class?
Yes, ma'am.
Yes, ma'am. 2 pi r h, ma'am.
Children, don't recall what you've learned in school. Have we discussed here in this class?
Yes, ma'am, we've discussed it in the class.
Okay, fine. Fine. So the lateral curve is 2 RH. Okay. So we work lateral surface area of cuboid. Oh, sorry, of cylinder. Lateral surface area of cylinder. Okay, lateral surface area of cylinder is equal to 2 pi RH. That is equal to 2 into 22 by 7 into radius. What's the radius, children? What is the radius?
Ma'am, 7, ma'am.
7, ma'am.
7 is the radius?
No, ma'am, it's 3.5. 7 is the diameter, ma'am.
Yeah, 7 is the diameter. The 7 by 2. 7 is the diameter of the circle. 7 is the diameter. Radius is half of the diameter, 7 by 2. Into what is the height of the cylinder?
7 centimeter.
7 centimeter, ma'am.
7. So this is 2 and 2 cancel, 7 and 7
7
cancel.
into 3.5 into 7, ma'am.
No, I have not taken 3.5. I have taken 7 by 2. So 22 into 154 centimeters square. Area of a is equal to 2h into L plus B. Oh, this is a cube, right? It's not a cuboid. I think I've been saying cuboid all the while. It's a cube, children. Okay, a cube also has 8 corners. I think I wrote cuboid earlier, children. I did not.
Ma'am, the voice is breaking, ma'am.
Sorry, earlier I wrote cuboid. Please change that to cube. Both cylinder and cube are solids. A cylinder has no corners while a cube has 8 corners. Cube, not cuboid. LSA of cube is equal to, what's the formula to find the lateral surface area of a cube?
4a square, ma'am.
4a square. 4a square. What's the value of a?
7, ma'am.
Very good. It's not 7 by 2, children. When it's diameter, radius is 7 by 2. So 4 into 49. 3 carry over 196 centimeters squared. So which box has, this is a cylindrical box, this is a cubical box. Both are boxes. One is a cylindrical box, the other is a cubical box. So which box has larger lateral surface area? The cubical box has larger lateral surface area than the cylindrical box. The cubical box has larger lateral surface area than the cylindrical box. Please write down.
Yes, ma'am.
Very good. Done, children?
Yes, ma'am.
All right. A closed cylindrical tank Closed cylindrical tank means now the tank can even be open at the top, right? A tank. Now this one is a cylindrical tank. If the cylindrical tank does not have a lid, if it does not have a lid, then it will be open here. If it has a lid, it will be closed. Closed cylindrical tank. That means, see, when it is a tank, obviously, the body, this will be the body of the tank. And this is the bottom of the tank. All this will be present. It's a tank. It's a tank. Okay, if it's a tank, then this curved surface area will be there. And the bottom circle will be there. The question is the top circle closed or open? The bottom circle will be closed. This is closed because it's a tank. It should hold water. So the bottom circle is closed, it's covered. What about the top circle? Is it open or closed? It's closed because it's a closed cylindrical tank. Meaning there is a lid here. So it's closed. See, when it's a tank, that means there is the curved surface area. And then there is also area at the bottom. Because it's a tank, it should hold water. Now the question is the top open or closed? Since it's a closed tank, the top has a lid. So it's closed. Radius and height is given. The question is how much sheet of metal is required. Now you will use the metal to make the body of the tank, right? You will use the metal sheet to make the curve, to build the curved surface area, and then to make the circle for the bottom and to make the circle for the top. Where will you use the sheet? The sheet will be used to build the body of the tank. The sheet will be, the metal sheet will be used to build the body of the tank. And what makes the body of the tank? The curved surface area, the area of the circle at the bottom, the area of the circle at the top. So the total surface area, you need to find the total surface area to find the, the amount of metal sheet required. Because the metal sheet is going to be used to make the body of the tank. When it is the body of the tank, it is the area of the tank. So you just have to find the TSA. So the area of metal sheet needed will be y 2 pi r into r plus h, because you have to find the total surface area. Why total surface area? Because it's a closed tank. It's covered all over. Is it understood, children?
Yes, ma'am. Yes, ma'am.
Now, finish this and think of this question. Supposing it is an open tank, open cylindrical tank, then what will be the area of sheet needed?
Ma'am, it will be curved surface area, ma'am. That is 2 pi RH.
Okay, then that's all.
No, ma'am. Then it would be 2 into 22 by 7 into 7.
No, I want only the formula. Okay, CSA find 2 pi RH. That's all. Only 2 pi RH.
Yeah,
That means
like the base is closed, no, ma'am, or it's open.
no. Then see if I say tumbler, when I say tumbler.
Yes, ma'am, and then it's plus R.
So like that when we say a cylindrical tumbler, when I say a cylindrical tumbler, the question of is the bottom of the tumbler closed or open is understood, because when it's closed, Because when we say tumbler, it's open at the top. It's covered below.
Yes, ma'am.
Similarly, when we use the word tank, tank means the bottom has to be covered. Only then it can be a tank. The bottom has to be covered. The top is open. The top circle is open. So what will be the area of the bottom circle?
Radius, ma'am.
No, area of the bottom.
Ma'am, it's 2 pi r. Pi r square, ma'am.
Pi r square. Pi r square. So you can make a note of this. Supposing it is an open cylindrical tank. For closed cylindrical tank, for closed cylindrical tank, it is a TSA, which is 2 pi r into r plus h. For an open cylindrical tank, not cuboidal, cylindrical tank, it is the CSA plus area of base, area of bottom or area of base. The CSA, because top area is not there, it's open. There is no area on the top. You will not use any material for the top because it's open, it's an open tank. The top is open. CSA is 2 pi RH. So you should find 2 pi RH plus the circle area, the area of the bottom circle, pi r square. Pi circle because cylindrical, no, so it will be a circle below. So you should find 2 pi RH. You must find pi r square and add both. That will be the area of an open cylindrical tank. Is it understood?
Yes, ma'am.
Please make note of that. Next one. The lateral surface area of a hollow cylinder. That means now if you tear a paper from your notebook, if you pull out one sheet of paper from your notebook and you bring the opposite edges together, you can make a cylinder, right? See, this is the paper which you pulled out from your notebook. If you roll it and bring this edge and this edge together, you roll it and bring the opposite edges together. Don't you get a cylinder? Not following
Ma'am,
Oh
your
my
voice
God,
is
am I
breaking.
audible?
Ma'am, your voice is breaking, ma'am.
Sir, the voice is not clear, ma'am.
Okay. Is it clear or breaking, children?
Ma'am,
Now
sometimes
it's
it's
clear, ma'am,
breaking.
but
Is it
previously
clear for
it was
anyone?
breaking.
Oh my God, what happened today? It's never happened, right?
Ma'am, we couldn't hear you properly.
Ma'am, now also it's breaking, ma'am. Ma'am, sometimes it's okay, ma'am, but sometimes it's breaking loose.
1 second.
Ma'am, I think there might be a problem with your microphone or something like that, ma'am.
Okay, I'm not sure. Okay, just let me know when I'm not clear. Huh?
Yes, ma'am.
Yeah. I've just changed my network. Let's see how this works. Okay. So I was telling you that if you pull out a sheet of paper from your notebook, all right. So this is the sheet of paper which you pulled out from your notebook, and you roll it. You roll this piece of paper so that you bring the opposite edges together. You roll it. You bring these two edges together. You roll it and bring these two edges together. What will you get?
Ma'am, a cylinder.
A cylinder. Can you see through the cylinder? From
Yes,
my
ma'am.
one end, can you see? That is a hollow cylinder. That is a hollow cylinder. So a hollow cylinder is from a piece of paper. Using a piece of paper, if you bring the opposite edges together, using a piece of paper, supposing you bring these two edges together, you roll it and you bring these two edges together, you will get a cylinder. You will get a cylinder, but it will be open at both the ends. You'll get a cylinder, but it will be open at both the ends. From this end, you can see this. From this end, you can see through this end. That is a hollow cylinder. Is it fine? Hollow cylinder?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Open at both the ends. Both the circles are open. There is no material there. You can see the circle, but it's open. There will be no material there. Supposing you have to paint a hollow cylinder, you will have to paint only 2 pi RH because it's only CSA. There are the two circles are missing. If you have to paint a hollow cylinder, the hollow cylinder has no material on the top and bottom. Only CSA is there for a hollow cylinder. So where will you paint? You'll paint only the CSA. 2 pi RH you will paint. You cannot paint here. There's nothing. It's open. You can't paint here. This is open. You can't paint here. You'll paint only the CSA. So 2 pi RH. Now here what you see is the curved surface area, the lateral surface area of a hollow cylinder is given to you. It is cut along its height. So the cylinder is cut along its height to form a rectangular sheet. Yeah, no, if you cut the cylinder, then when you open it, it will be a rectangular sheet. From a rectangular sheet, you can make a hollow cylinder. If you cut the hollow cylinder, you will get a rectangular sheet. Yes or no?
Yes, ma'am.
See, supposing this is the hollow cylinder. Okay, if you cut it like this, you use a scissor and you cut it here. You cut like this. You cut it like this. Then you can open it up. You can open it up and you will see it will open to a rectangle.
Yes, ma'am.
Yeah, see, from your notebook paper, you can bring the edges and make a cylinder, right? So if you cut the cylinder, you will get a paper, a rectangular paper.
Yes, ma'am.
Okay, so the width is 33 centimeters. This one is 33 centimeters. You should find the perimeter of the rectangular sheet. You should find the perimeter of the rectangular sheet. Now we got this. Okay. So for the hollow cylinder, what are you given? You're given the curved surface area. You're given the curved surface area. Okay. And it is cut along the height. And it opens to a rectangle. It opens to a rectangle of width 33 centimeters. Find the perimeter of the rectangular sheet. So whatever is the CSA of the hollow cylinder will be the area of the rectangular sheet of paper. What you call this curved surface area of the cylinder will be equal to the area of the rectangular sheet of paper. Because that CSA, when you cut it open, it becomes a rectangle. For a cylinder, you say curved surface area. But when it becomes a rectangle, when you cut it and it becomes a rectangle, you will say area of the rectangle. The same thing is called the area of the rectangle. The curved surface area of the cylinder, when you cut it open, it becomes a rectangle. So the curved surface area of the cylinder is nothing but the area of the rectangle. The curved surface area is nothing but the area of the rectangle, area of rectangle. So that means the area of the rectangle is how much? Area of rectangle is 4224. That means L into B is equal to 4224. So L into B 33 is equal to 4224. Should work this and find the length. L is equal to 4224 divided by 33. Find the length. And now you know the length and breadth. Find the perimeter. Please work, children. Am I clear, children? Am I audible and clear?
Yes,
Yes,
ma'am.
ma'am.
Okay. Danya, I don't know why is she on hold. Well, I cannot do that. Okay, Keetana, Madhumita, Sanjay, and Sindhu, Devadarshini. Am I audible and clear?
Yes, ma'am.
Yes, ma'am.
Okay. Yes, children. So please visualize this. Please visualize what is the, so what you have to visualize is a piece of paper. You bring the opposite edges together and you have a hollow cylinder in your hand. What you call as the curved surface area of the cylinder, when you spread it open, is the area of the rectangle. So the curved surface area of a hollow cylinder becomes the area of the rectangle when you spread it open. So what is given is the LSA of the cylinder, but that's nothing but the area of the rectangular sheet. So L into B, area of rectangular sheet is L into B. So L into 33 is equal to 4,224. L is 128 centimeters. Perimeter is 2 of L plus B. And the answer is 322 centimeters. Is it understood?
Yes, ma'am.
Yes, ma'am.
Okay. When a road roller, you can see it's cylindrical. Okay, the road roller, you can see that the roller is cylindrical. Now, what part of the roller, what part of the cylindrical roller comes in contact with the ground? What rubs over the ground? The total surface area rubs over the ground or the curved surface area rubs over the ground?
Curved surface area.
Curved surface area.
Yeah, when a road roller moves, on a road to level the road or to level a playground, whatever, it is the curved surface area of the roller that comes in contact with the ground. The total surface area has got nothing to do with the ground. What constantly rubs over the ground is the curved surface area. Repeatedly, it keeps moving over the ground. Now, supposing okay, so supposing this is a piece of land. Okay, this is a piece of land. I have a roller. I have a hand roller. Okay, I have a hand roller, not one like this. I can move the roller with my hand. I have it. It's fixed to a long stick. I hold the stick and see. I can't draw it exactly, but so the roller is long like this, and I have. There's a long stick. I can hold the stick and keep rolling it over the ground. Do you understand the situation?
Yes, ma'am.
Yes.
So imagine that I have a roller. See, this is the piece of land which I want to level. This piece of land is all in ups and downs. So I'm trying to level this land using a roller. So the roller just fits. It's exactly like this. Now, supposing this roller, I move the roller some 10 times. This roller rolls over the ground 10 times to level the ground. This roller, you understand what one complete revolution is. So supposing this part is in contact with the ground, it rolls, and when the same part comes in contact with the ground, that's one revolution. Now see here. Now see here, this portion is in contact with the ground. When this roller rolls, so it's here, like if it rolls and makes one complete circle and comes back to the same position, it's one revolution. It's one revolution. Now this point is in contact with the ground. So when it goes up, when this portion, it will go up, no, it will go up and go up and go up. And when it comes back here, it's 1 revolution. Now say that this roller has to make 10 revolutions to level this ground. Then the area of this ground will be the CSA of the roller into 10. Because 10 times, it would have 10 times meaning 10 revolutions it is made. In 1 revolution, the area is CSA. What area, what rolls over the ground in 1 revolution? The CSA. In 1 revolution, the entire CSA would have rubbed over the ground. In 1 revolution, the entire CSA would have rubbed over the ground. So the area covered in 1 revolution is equal to CSA. The area covered in 2 revolutions will be 2 into CSA. The area covered in 3 revolutions will be 3 into CSA. So if it goes 10 times, 10 into CSA, that will be the area of the playground. Whatever is the curved surface area of the roller into the number of times it rolls will be the area of that ground, or whatever flat, whatever surface it is. So in this question, a road roller takes 750 complete revolutions to move once over to level a road. So to level the road, the roller has to go 750 complete revolutions. So 750 into CSA will be the area of the road. 750 into CSA of the roller. Because CSA is the area covered in 1 revolution. The area covered in 1 revolution is CSA. So the area covered in 750 revolutions will be 750 into CSA. And that will be equal to the area of the road. Please take down the answer, children. Children, substitution, you can do it like this. Don't substitute like this. You can take 2 into, that is equal to 2 into 22 by 7. Let me work it below. No, I'm saying just take this. I'll change it here, okay? I'll change it here. 2 into 22 by 7 into radius. The diameter is 84, so the radius will be 42 centimeters. 42 centimeters. 1 minute. Let me work it completely for you. Please wait. Write on like this, roller, road roller. Please write like this. I'll just continue working here, children. You please work below. I'll just continue here. 2 into 22/7 into radius to height 100. You follow, children?
Yes, ma'am.
Okay. I've found the I've had the values in centimeter. You should substitute all in the same unit. You cannot have one value in centimeter and the other value in meter in one formula. In the same formula, you cannot substitute one value in centimeter and the other value in meter. The values, all the values in the formula should be in centimeter or meter or the same unit. So I've had the radius as 42 centimeters and height is 100 centimeters. 1 meter is 100 centimeter. So you will get the answer in centimeter square. And to convert that to meter square, centimeter to meter divided by 100. Centimeter square to meter square, 100 into 100 divided by 100 into 100. Do 2 times. So 1980 meters square. Is it understood, children?
Yes, ma'am.
All right. Finish writing?
Yes, ma'am.
Yes, ma'am.
Please read the question. I'll give you some time. Read the question for yourself and be ready to answer my questions. All right. What is the shape? What shape will the label take?
Ma'am, it's a rectangle.
No, okay, yeah, fine. The label is originally a rectangle. When it goes around the cylindrical, what is it called? Cylindrical container. When it goes around the cylindrical container, how does it look now? The label, is it still rectangular?
No, ma'am, it looks like a hollow cylinder.
Yeah, it becomes a hollow cylinder. Now, your label, your label, the label which you put on your notebooks and textbooks, that label, when you put it on the text, it's rectangular. When you put it on your notebook also, it's rectangular. Rectangular or square, whatever. When you, like you put it on your notebook or your textbook, the label is still rectangular or square in shape. But this label, when it goes around the cylindrical container, the body of the cylindrical container, the label also looks cylindrical now. Yes or no?
Yes, ma'am.
Okay. What is the height of the container?
20 centimeter, ma'am.
20 centimeter, ma'am.
Correct. What is the height of the label? Height of the label.
Ma'am, 20 minus 4, ma'am. 16.
16, ma'am.
16. Because 20 is the total height of the container. Minus 2 on the top, minus 2 below. So 20 minus 4, 16 centimeters is the height of the label. What is the radius of the container?
Ma'am, 7 centimeter, ma'am.
Very good. What is the radius of the label? The label is now looking cylindrical. What is the radius?
7 centimeter, ma'am.
7 centimeters.
7 centimeter, ma'am.
Yeah. Now what is that we have to find? What is the area of the label? The label looks cylindrical, right? And it is a hollow cylinder. It has only the curved surface area. So what's the formula to find the curved surface area of a cylinder?
Ma'am, it's 2 pi r h plus pi r square.
2 pi r h, ma'am.
2 pi r h. No, the label is not stuck at the bottom. The label goes only around the CSU of the container. Y plus area of the bottom of the container is covered. The label is not stuck at the bottom.
Yes, ma'am, I got confused.
Yeah. The container's bottom, it's a container, so the bottom will be covered. If you have to find the area of the container, yeah, then is it given if it's an open or a closed container? Milk powder, cylindrical container, height. No, we don't know if the container is open or closed. Here the question is not about the container. If it's an open container, then as you said, Madhumita, you'll have to find 2 pi rh plus pi r square.
Yes, ma'am.
Here it's about the
Asking about the label only, ma'am.
correct. Yeah, here the question is only about the label. So only 2 pi rh you'll have to find. Correct?
Yes, ma'am.
So you all said the radius is 7 and the height is 16, not 20. 16.
Yes, ma'am. 2 from front, up and 2 from
Correct.
bottom.
What will you take the height as 20? To find what you will take the height as 20?
Ma'am, for the container, ma'am.
Container. You have to find the CS of the container, you will take the height as 20. Yeah, please write down.
Ma'am, we can also do it like length into breadth, no, ma'am. 16 into 14.
No, 14 is just imagine only the diameter is 14. The length of the label is not 14.
Yes, ma'am.
The length of the label.
Yes,
It's not the length of the label will not be equal to the diameter of the cylinder. It will be more than that.
yes, ma'am. I get it.
Yeah. That 14 given there is not the length of the label. As you have understood, the breadth of the label is 16 centimeters, but the length of the label is not 14. That's the diameter of the circle.
Ma'am wrote, ma'am.
Yeah. You can just call this capital H because you cannot use the same H everywhere. You can use a capital H here. Just to differentiate.
Completed, ma'am.
All right. Class, use the emoji. Raise your hand. Sindhu and Sanjay, Keertana, Madhumita. What about Devadarshini? No response. Divya. Oh, sorry, Danya is on board. All right. I hope all of you finished writing. Finished writing, children?
Yes, ma'am.
Yes, ma'am.
All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you, ma'am. Thank you. Good
Thank
night.
you, ma'am.
Thank you, children. Good night.